Now, we had done one thing previously, and that was that we learned about bond energies, and we talked about bond breaking bonds and forming bonds. In any reaction, you're breaking and forming bonds. You can calculate the enthalpy change because it's the energy that is needed to break bonds, and it's the energy that would be released during bond formation. So if you know how many bonds are broken and how many bonds are formed, you can figure out the enthalpy change or overall energy change of that particular reaction. Now, the only problem with this is that I told you that the data booklet bond energies are defined for gaseous substances. So don't use them, or don't use this method if the substance is either a solid or a liquid. Now, we're going to move towards other techniques of finding enthalpy changes, but before we could do that, there are a lot of definitions that we have to remember. Uh, so, plenty of definitions that have to be remembered. So, what's going to happen is that from now on, uh, whenever there's a reaction, a reactant changes into a product and it has a particular enthalpy change. Uh, we're going to call that or name or give it a name, a very specific name to that enthalpy change, uh, depending on what type of reaction it is, because we can't really uh, write the equation every time. It becomes a lot easier to communicate. For example, if there's this reaction going on and it has a particular energy change which is minus 88, I'm going to name this or label this energy change so that if I want to communicate it with someone, I don't have to write the whole equation and explain to them that this is the energy change that is associated with this particular reaction. By assigning labels, I can the communication becomes a lot easier. So which is why enthalpy changes are going to be labeled from now on. Starting with the first one that we're going to do is called the standard. So I'm just going to use short enthalpy change. Okay, so I've just abbreviated them of formation. So that's the first one. Uh, and the sign or the label of the enthalpy change would be delta H with a small f at the bottom, and there's going to be a circle at the top. That circle indicates that the energy change is measured under standard conditions. So whenever the word standard is written, that means whatever is happening, it's happening, and whatever calculations you're making, that's happening under standard conditions, which are basically what are standard conditions? That's 298 kelvins. That's basically 298 kelvins. So that's basically 25 degrees centigrade. That's room temperature. The other thing is that when you talk about standard, you talk about the atmospheric pressure, which is going to be 1 atmosphere. And finally, if it's a solution, the solution would have a concentration of 1 mole per. It's going to have a concentration of 1 mole per decimeter cube. So that's your standard conditions. Now, what is enthalpy change of formation? Not only do you need to know what it is, you need to memorize the definition as well, because you're going to be asked about it. So it's energy released or absorbed in a very specific reaction, and that reaction is released or absorbed. What this first line means is that it could be endo as well as exo. So remember, it's going to have a sign. It could be plus, it could be minus, uh, and you have to remember that as well. So energy released or absorbed in a very specific reaction. What is that reaction? When 1 mole of a substance is formed. When 1 mole of a compound is formed, so whenever you see 1 mole of a compound being formed in a reaction, uh, and formed from what? Formed from its constituent elements in this standard state. And it's measured under standard conditions. I mean, this last statement would always be there. If you
Constituent meaning?
whatever it's made up of. Okay, for example, I'll do an example. Uh, so what is enthalpy of formation? It's the energy change. It's the label given to the energy change of a particular reaction where you're forming 1 mole of a compound, and it's formed. And it's formed from its constituent elements, whatever elements it's made from, and the elements must be in the standard state. This is the state of the element at room temperature at 298 kelvins. Uh, for example, you've got all these elements. You've got carbon, you've got hydrogen, you've got oxygen, you've got iodine, right? And let's add bromine as well. Now, what is the standard state? The standard state of carbon is that at room temperature, carbon is a solid. I mean, carbon could be graphite or it could be diamond. What is the condition of hydrogen at room temperature? What is the state of hydrogen? Hydrogen is a diatomic gas at room temperature. What is oxygen, the element at room temperature? That's also a diatomic gas at room temperature. What is iodine? Iodine is a solid. It's a blue-black solid at room temperature, and bromine is a red-brown liquid at room temperature. So you should be aware of what the state of the element is under standard conditions, which is basically room temperature. So you're trying to make 1 mole of a compound from its constituent element. For example, okay, let's try one. Let's 1 mole of a compound. Let's take ethanol, C2H5 and OH. So I'm taking ethanol, 1 mole of a compound, and it's formed from its constituent elements. What are the elements? It's carbon and hydrogen and oxygen. These are the three elements that it is made up of. The elements must be in their standard state. So make sure that carbon is a solid. Hydrogen over here is a diatomic gas. And oxygen is also a diatomic. It's a diatomic gas. So they're all gases. Uh, and remember, it has to be 1 mole of a substance. So which means that this must be kept 1 mole. So it's the enthalpy change of a reaction where you're making 1 mole of a substance from its constituent elements. So you balance accordingly. There should be 2 carbons, there should be 6 hydrogens, so there would be 3 H2 gas molecules, and there's going to be half O2 gas molecules. So the enthalpy change of this particular reaction, whatever the energy change is, whether it's endothermic or exothermic, it will be assigned a label which would be called the enthalpy of formation of ethanol, C2H5 OH. So this would be the label that would be assigned. So next time, if you want to convey it to someone that you're talking about the energy change of this particular reaction, what you're only going to tell them is that the enthalpy of formation of ethanol, which is this one, has this particular value. And he'll understand what the reaction is. So you don't have to explain whatever is going on. You'll just tell them the label that it's enthalpy of formation of ethanol. So the energy change that is associated with this reaction would be called the enthalpy of formation of ethanol. And if it's done under standard conditions, you put a not on top. Let's do another one. Let's do another 1 mole of a substance is formed from its constituent element. So let's say 1 mole of water is formed, which is liquid at room temperature from its constituent elements. So the elements are, you've got H2, which is gas, diatomic, and the other element is oxygen, which is also diatomic, and it's a gas. And again, this at all costs has to be kept as 1 mole. So if you keep that as 1 mole, then O2 would have to be multiplied by half. So this reaction, the enthalpy change or energy change of this reaction would be called the enthalpy of formation of H2O, because in this reaction you're making 1 mole of water from its elements. So you're going to call the energy change. The energy change is going to have a value. It's going to have, it could be 100 kilojoules, 200 kilojoules, whatever the value is. They're all going to have some sort of value. Let's do the enthalpy of formation of. So I'm going to write down these labels, and one by one we're going to try and do them. So if somebody says that enthalpy of formation of SO3 has a particular value, which reaction is he talking about? Can you even tell me? What would be the equation? Like if somebody says that this is, hypothetically speaking, minus 94 kilojoules per mole. So can anyone tell me what is the reaction? Whose enthalpy change is he talking about? Anyone? Mariam? Anna? Nabila, do you know this?
Of sulfur and oxygen?
Like what's the definition? Okay, it's the reaction in which 1 mole of SO3 is going to be produced, right? So you're going to be producing 1 mole of SO3 from its constituent elements. What are the elements? It's sulfur and it's oxygen, right?
Oxygen.
So this is the energy change that is associated with this reaction. It's not balanced yet. Plus, you always have to remember. You always have to write states. Remember, sulfur is a solid. It's a yellow solid. I'll just show you a picture so you always remember what sulfur is. Uh, so this is sulfur. It's a yellow solid. Sometimes it's a powdered substance. So this is what sulfur looks like. So coming back to this, 1 mole of SO3 would be produced from its constituent elements. Now we've got 3 oxygens over here. In this reaction, 1 mole has to be produced. So over here, they should be multiplied by 3 by 2. And don't forget writing the states. I mean, you should know what SO3 is. SO3 is a gas. Let's do another one. Let's say I have somebody tells me that enthalpy of formation of so enthalpy of formation of CBr3 COOH has a particular value. Let's say minus, hypothetically speaking, minus 200 kilojoules per mole. So he gave me the energy change of what reaction? What is the reaction? Can anyone tell me? Abdullah? Mahad, any idea? Kausar?
Carbon plus bromine plus oxygen plus hydrogen.
Okay. So it's basically 1 mole of a substance must be formed. So you're trying to make CBr3, COOH, and let's say that, I'll just give you this, that this is a liquid. It should be formed from its elements. The elements are going to be carbon plus bromine plus oxygen plus hydrogen. And the elements, they have to be in their standard state. The states of each of the elements at room temperature are going to be: carbon would be a solid, bromine is going to be Br2 and it's going to be a liquid. Oxygen is O2 at room temperature, it's a gas, and hydrogen is H2 as well. It's diatomic and it's also a gas. And this has to be kept as 1 mole at all cost. So there are 2 carbons on the other side, and you've got how many bromines? 3. So I'm going to multiply this by 3 by 2, or 1.5. And how many oxygens do I have? I've got 2 oxygens and I've got only 1 hydrogen, so that would be half. So the energy change of this particular reaction, where I make 1 mole of a substance from its constituent elements, that's your enthalpy change of formation. And if it's measured under standard conditions, then if you're doing this at room temperature, then there's going to be this knot over here. Is this clear to everyone?
Yes.
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 So remember this, remember the definition that because from now on, they won't tell you what the reaction is. From now on, you'll only see this. I mean, the question, you'll only see this, that the enthalpy of formation of SO3 is minus 94 kilojoules per mole. So you're going to figure out the reaction yourself. They're just going to tell you that the enthalpy of formation of CBr3COH is minus 200. So you're going to figure out the reaction on your own. Which reaction is he talking about? So that's one. I'm also going to add a point over here, that is that enthalpy of formation of elements is zero. So the enthalpy change of formation of elements is zero. Why is that zero? Because you don't have to form elements. That's why. For example, if you're talking about the enthalpy of formation of if somebody is talking about the enthalpy of formation of an element uh, like O2, then why is it zero? Because by definition, you're going to form 1 mole of O2 from its constituent element, which is also oxygen, and the element should be in its standard state, which is O2. So you're basically not doing anything. So since you're not doing anything, the enthalpy of formation of elements is going to be zero. And remember that this thing, that it's very important. It's going to be, this is going to help you out in questions that we'll solve later on. Now, the next thing that we're going to talk about is the next definition, which is enthalpy change of, I said the next one is the standard enthalpy change of combustion. So standard, so just putting it out there, enthalpy change of combustion. Now, by just looking at the name, it's a combustion reaction. It's a reaction which is by default going to be exothermic. So I mean, all combustion reactions are. So all combustion reactions are by default. They are exothermic. Uh, and combustion is a reaction with oxygen. So when we talk about enthalpy change of combustion, the symbol is delta HC. And if there's a knot on top, that means standard condition. So that would be the standard enthalpy change of combustion, which is at room temperature. So it's always exothermic. It's always going to have a negative value. It's going to be producing energy. So what's the definition? You'll be asked about the definition. So this one is, it's going to be the energy that is released when what happens? When combustion happens. So it's the energy released when 1 mole of a substance. So it's not just any combustion, it has to be a very specific type of combustion. When 1 mole of a substance burns in excess oxygen. So what this excess oxygen means, that it has to be a complete combustion. You can remember, it's not going to be incomplete combustion, but it has to be a complete combustion reaction. Energy released when 1 mole of a substance burns in excess oxygen measured under standard conditions. So at room temperature, so you're burning something and you're trying to figure out how much energy is released when that happens. So for example, you're told that enthalpy of combustion of carbon has a particular value. Here again, all these values are just made up. So in the question they tell you this, that enthalpy change of combustion of carbon is minus 90 kilojoules per mole. So what reaction are they referring to? It's the reaction when 1 mole of carbon burns in oxygen to produce. So you must have some idea of what it produces. It should be producing carbon dioxide. So it's the enthalpy change or energy change that is associated with this reaction when 1 mole of carbon, and since it's being measured under standard conditions, so everything should be in its standard state. So this is the reaction that they are talking about. If they tell you that enthalpy change of combustion of, in the question they tell you that enthalpy change of combustion of, let's say, ethanol has this value. So what reaction are they talking about? It's a reaction in which 1 mole of ethanol, which is C2H5OH, and it burns in excess oxygen to produce CO2 and H2O. Okay, so hopefully everyone remembers what happens when hydrocarbons burn. They produce carbon dioxide and water. So this is liquid, this is gas, this is gas as well. This is going to be at room temperature, it's going to be liquid. So this has to be 1 mole. So there's 2 carbons, there are 3 water molecules, and there are going to be 3 oxygen gas molecules. So the substance at all cost has to be 1 mole. It has to be 1 mole of a substance. So you can keep doing this. So it's energy released when a substance burns in excess oxygen. And also remember that not any reaction with oxygen is a combustion reaction. It has to be a spontaneous combustion reaction, like the one that you see. Like if you burn paper, so that's a spontaneous combustion reaction. So it has to be spontaneous. Like not every reaction with oxygen is considered to be a combustion reaction. Like for example, you have iron reacting with oxygen, rusting, but that's not combustion. That's I mean, although it is iron reacting with oxygen, but it's not iron burning in oxygen. So it has to be a spontaneous combustion reaction, and it has to be a complete combustion reaction. Like if you see an equation where carbon reacts with oxygen and produces carbon monoxide, then carbon monoxide, that's not going to be called the standard enthalpy change of combustion, because it has to fully react with oxygen. Is this clear to everyone?
Yes.
Yeah.
Achha, so let's do a few more equations. Also remember what things form what thing. Like if you're given the enthalpy of combustion of hydrogen, and they tell you that that has a value of minus 180 kilojoules per mole. So it's the enthalpy change of a reaction where 1 mole of H2 burns in excess oxygen, and when H2 burns in oxygen, it produces H2O. So it has to be 1 mole, so I have to make oxygen gas half. So 1 mole of H2 burns, and everything should be in their standard state. So this is known as the enthalpy of combustion of H2. Similarly, for some compounds, you should know what do they form when they burn. One example is people get confused about the enthalpy of combustion of sulfur. If you're given this value and you want to know whose enthalpy change is this, which reaction produces this much energy. So it's the reaction where 1 mole of sulfur burns in excess oxygen to produce SO2, not SO3. Remember, forming SO3 is a very difficult process. That's not combustion. If sulfur burns, then it spontaneously burns and produces SO2. It rarely produces SO3. I mean, making SO3 is kind of very hard, which is why you have the contact process. So it's kind of really, really hard. Usually, it's SO2 that's being produced. So you have to be careful about that as well. So remember this. From now on, they won't tell you what the equation is. Whose energy change are we talking about? They'll just give you a symbol, a label that would, and using that label, the label would be self-explanatory, and using that, you can figure out what the reaction they're talking about. Now, there would be certain reactions that are going to have multiple labels. For example, I mean, for the same reaction, you can have multiple labels. So you can classify things in multiple ways. So one example is I have this reaction, and I've got carbon reacting with oxygen and producing carbon dioxide, right? So they are standard conditions. Now, the enthalpy change or energy change of this reaction, I can call it, if I want to label it, I can call it the enthalpy of combustion of carbon. Why? Because in this particular reaction, there's 1 mole of carbon that's burning in oxygen to produce carbon dioxide. So calling it enthalpy of combustion of carbon is not, I mean, the energy change of this reaction can be called the enthalpy of combustion of carbon. But at the same time, I can also call the same reaction, the energy change of the same reaction, I can call it the enthalpy of formation of carbon dioxide. Why? Because in enthalpy of formation of carbon dioxide, the definition is 1 mole of carbon dioxide should be formed from its constituent elements, which is also true. So the energy change associated with this reaction can be called multiple things. It could be called the enthalpy of combustion of carbon. It could also be called the enthalpy of formation of CO2 as well. Is this clear? Mariam, is this clear? Mahad?
Yes.
Yeah.
Yes.
Okay, so you can call it multiple things. Same is true for this one. For example, you have H2. So because in the questions they can trick you around. Like you're looking for enthalpy of combustion of carbon. For example, in the question when we solve questions later on, and there's a requirement, and you're looking for enthalpy of combustion of carbon. But in the question, they've given you enthalpy of formation of carbon dioxide. So remember, they're basically exactly the same thing. So a lot of people actually get things like this wrong. Similarly, you have H2 and O2 reacting to form H2O. And this is not solid. H2 is not solid, never solid. It's a gas. And H2O over here is a liquid. So this is half O2. So now for this one, again, I can assign the energy change of this reaction multiple labels. I can call it the enthalpy of combustion of H2, because there's 1 mole of H2 that's burning in oxygen to produce H2O. Or vice versa, I can also call it the enthalpy of formation of H2O, because 1 mole of H2O is formed from its constituent elements. So both of them, they represent the same energy change. They have exactly the same value, because they represent the energy change that is associated with the same reaction. So they are exactly the same. And yes, Abdullah.
When we learn more definitions for enthalpy changes, so when we come back to these reactions, will they be having more enthalpy change, or will they be like having these two only?
I mean, they can have possibly more. Like you can assign more labels to them. At the moment, I think these are the only two labels that can be assigned to them.
Okay, so thanks.
Acha, but for a lot, there's only one label. For example, this one. This reaction over here can only be called enthalpy of combustion of ethanol, because 1 mole of ethanol burns in oxygen to produce carbon dioxide and H2O. You can't call it enthalpy of formation, because It's not the enthalpy of formation of anything. Enthalpy of formation is when you form a compound from its elements. So it's obviously not being formed from its elements. So you can't. So there's only one label assigned to this. So so most of them you can't assign multiple labels. For example, this would always be called enthalpy of formation of this thing. You can't call it enthalpy of combustion of something because nothing is burning. There is no spontaneous reaction. This is not combustion. So only a few times the same reaction can have multiple. It can have multiple names. So I'm going to write a few equations. Quickly tell me what this is. 2 carbons plus 2H2. I've got C2H4, which is ethene. So the energy change that is associated with this reaction, what can I call it? What label can I assign?
Formation.
Formation.
Okay, so this is 1 mole of ethene is formed. I can call it the enthalpy of formation of C2H4. So it's the enthalpy of formation of C2H4 because it's being formed from its elements. What about this one? I've got 2H2 plus 2O2. And it's forming 2H2O2.
Multiple enthalpy changes. Formation and
Sorry,
combustion.
the first thing, when H2 burns in oxygen, what does it produce? Does it produce? This is hydrogen peroxide. That's never produced. Okay, you must know that this is not combustion because when you burn H2, you get water. You don't get H2O2. Abdullah, is this clear?
Okay, I'm sorry. Yes.
That's exactly why I wrote this equation. That I told you that enthalpy of combustion is the spontaneous reaction that happens. So H2, remember H2 would always produce H2O. It's going to produce water. Uh, and even in organic compounds, the hydrogen in the organic compound always produces H2O. Hydrogen peroxide is a very deadly substance. It's never produced actually. Uh, so it's definitely not the enthalpy. If you call it the enthalpy of combustion of H2, that's wrong. So what can I call it?
Enthalpy of formation of hydrogen peroxide.
Okay, you can call it the enthalpy of formation of H2O2 because H2O2, the compound is being formed from its elements. The elements are hydrogen and oxygen. But there's one thing wrong with this. What's wrong about calling
It's
it?
2 moles.
2 moles of
Because in enthalpy of formation, you make 1 mole. So the thing is, you can still call it this, except that it's twice the value. It's 2 times the enthalpy of formation of H2O2. Because if forming 1 mole of H2O2, let's say, produces minus 100 kilojoules of energy, then forming another mole of H2O2 would also produce minus 100 kilojoules of energy. So it's basically double that value. Okay, so you can still give it that label, but it's basically double that value. Is this clear?
Yes.
yes.
Yeah.
Okay. So just remember what is enthalpy of combustion, because next time you'll in your questions, in your past paper questions, you'll only be seeing this thing. You'll only be seeing. They won't write the reaction. They would just give you this. That's it. You have to figure out the reaction yourself. Like, whose enthalpy change is he talking about? So there are multiple. But I'll just leave it here because we don't have enough time. So try and write the enthalpy of formation of all these. I'm giving you an assignment, a small assignment, because that's number one. Write the equations, write the reactions. So that's number 4. And this one is number 5, which is enthalpy of combustion of, let's say, so these 5 give me the equations that correspond to these enthalpy change values. Okay. So let's continue. Next time I'll just post it on the uh, I'll send the board the classroom link as well. Just a second.
Okay, thank you.
Okay, then take care, everyone.
Thank you. Allah Hafiz.
Hafiz.
Allah Hafiz. Allah Hafiz.